I thank you all for watching my videos all these years. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Thank you. We now discuss the solution of a problem that appeared in the CSIR National Eligibility Test held in the month of June 2023. This question is from the section Real Analysis, and the question is framed using the Archimedean property. The question is from the part B, which is a MCQ. It carries 3 marks. The question ID is 704023. This question is suitable for all these examinations. Right. The given question is, let xy belongs to the closed interval 0, 1 be such that x not equal to y. Which of the following statements is true for every epsilon greater than 0? We are given 4 options. Option 1, there exists a positive integer n such that mod of x minus y less than 2 power n epsilon for every integer n greater than or equal to capital N. Option 2, there exists a positive integer n, capital N, such that 2 power n epsilon is less than modulus of x minus y for every integer n greater than or equal to capital N. Option 3, there exists a positive integer n such that mod of x minus y less than 2 power minus n epsilon for every integer n greater than or equal to capital N. Option 4, for every positive integer capital N, mod of x minus y less than 2 power minus n epsilon for some integer n greater than or equal to capital N. Right. Let's now discuss the solution of the problem in detail. So that is the given question. Right. Let's now discuss the solution in detail. We have xy belongs to the closed and bounded interval 0, 1, that's the unit interval, and x not equal to y. Therefore, 0 less than modulus of x minus y less than 1. Yes, xy belongs to the closed and bounded 0 to 1. That will imply 0 less than mod of x minus y less than 1. Right. We call on option 1. There exists a natural number n such that mod of x minus y less than 2 power n into epsilon for all n greater than or equal to capital N. Agreed. We have epsilon greater than 0, right? Mod of x minus y greater than 0, right? We recall the famous Archimedean property of real numbers. For any 2 positive real numbers a and b, there exists a natural number n such that na greater than b. It's a very simple property of real numbers. Right. We use the Archimedean property here. So epsilon greater than 0, mod of x minus y greater than 0, by Archimedean property, there exists a natural number capital N such that Na greater than B, that is N epsilon, capital N epsilon greater than mod of x minus y. This implies there exists a natural number capital N such that mod of x minus y less than capital N into epsilon. Right? And for any natural number n, n is less than, capital N is less than 2 power n. Right? Right. Now, notice that when n, capital N is a natural number, 2 power n less than 2 power n plus 1, that means the power is increasing, therefore the value will increase, less than 2 power n plus 2, less than so on and so forth. That means from and after the capital nth stage, see this 2 power n will be less than all of them. So mod of x minus y less than 2 power n epsilon for all n, small n, greater than or equal to capital N, right, because of this. Thus, for every epsilon greater than 0, there exists a natural number n such that mod of x minus y less than 2 power n into epsilon for all small n greater than or equal to capital N. Right. We have obtained the option 1. Thus, option 1 is true. And the answer, and as this is a multiple choice question, only one answer is correct. Therefore, the answer to this question is option 1. So the question is over. And it's a very simple and straightforward question. But I will show you how the other options are false. Right. We take the option 2. There exists a natural number capital N such that 2 power small n epsilon is less than mod of x minus y for all n greater than or equal to capital N. This is not true. So where this fails, give a counter situation. Assume that this statement is true. Let x is equal to 0, y is equal to 1, no problem, because it's a closed interval, x, y belongs to the closed interval 0 to 1. You can take x is equal to 0, y is equal to 1. Epsilon is equal to 1 by 2. Right. Now, then there exists, because you are treating this statement is true, there exists a natural number capital N such that 2 power n epsilon is less than modulus of x minus y for all small n greater than or equal to capital N. This means there exists a natural number n such that 2 power n into epsilon is 1 by 2 is less than mod of x minus y is 1. X is 0, y is 1, mod of x minus y is 1. Now the situation is there any natural number, capital N, such that this happens for all n belongs to n greater than or equal to capital N? No. There is no such natural number, capital N. That means for no natural number n, this is true. Therefore, that your assumption, what you have made, is not true. Therefore, option 2 is not true. Now, we will move to options 3 and 4. Option 3, there exists a natural number n such that mod of x minus y less than 2 power minus n, small n, epsilon, for all small n greater than or equal to capital N. Option 4, for every natural number n, mod of x minus y is less than 2 power minus n epsilon for some n greater than or equal to capital N. Anyway, assume that both the statements are true. Let x is equal to 0, y is equal to 1, no problem. Epsilon is equal to 1 by 1, no problem. We take it. Then mod of x minus y less than 2 power minus n epsilon. In both the cases, this is given for all n greater than or equal to n. That is, mod of x minus y is 1 less than 2 power minus n small n. Is it true? For any natural number? For any natural number capital N? For no natural number n, this is true. This means to say 1 less than 2 power minus n means 2 power n is less than epsilon. 2 is exponentially growing. How can this be less than 1? So therefore, for no natural number, this is true. Therefore, that your assumption that the statements 3 and 4 are true is false. Therefore, option 3 and option 4 are not true. Thus, the answer to this question is option 1. That is the detailed discussion of the solution of the problem from the section real analysis, which is based on Archimedean property. And it is a very simple, sweet, straightforward question. I am sure that you have understood the solution of this problem. I thank you for watching this video now. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. I hope to meet you once again in another episode of learning. I wish you all the best. Thank you.